Hi, I'm here with Nic Jackson, and we are going to talk about Terraform and Azure today. And I am also, again, standing on a box while Seth gets a chair. So all I'm saying...
It's unfair.
It's unfair. It's, you know, you heard it here. Nic is going to show us some really cool things, and he says his demo cannot fail.
I said it might work.
Oh, okay. That's very different. Also, he can't code and smile at the same time. I've also been told, so...
Yeah, so if I look angry, it's not because I'm angry, it's because I'm not very good at multitasking.
Literally never been angry.
Ever.
All right, let's do this, man.
Awesome.
Oh, one more thing. I want to point out for Tyler, who's sitting in the other room, that Nic has some Go stickers on here. There's another Go developer in the room, Tyler.
Yeah, Go's awesome. Everybody should learn Go.
Truth.
So what we're going to do is have a look at a little demo of Terraform and how we can use Terraform to create a Kubernetes cluster and deploy something to Kubernetes.
Oh, but wait. What's Terraform?
Terraform's like an amazing thing, and it's glad you asked because I've got some slides about that. I do.
So are they corporate slides? I can't wait.
They're the thing that pay my wages. So these are. So I think that it's interesting, right? Because HashiCorp is pretty well known for its product. So we've got like Vagrant is one of the things that most people started using.
Sure.
And then we kind of build out that with Packer and Console and Nomad and Vault and Terraform. But the company was actually founded back in 2012 by Mitchell and Arman. And the concept was that they were looking at the market and thinking there's got to be a better way to be dealing with the problems that we're now facing, which is kind of more distributed systems, moving to cloud-based, but even potentially kind of looking at like cloud migration and all sorts of things like that. So a lot of people kind of associate or know the names of the products, don't actually realize that they're all managed by HashiCorp. So there's two problems that we kind of see, and that is that, like, these two problems are not mutually exclusive.
Right.
So you've got organizations who want to be able to manage and migrate some of their applications to the cloud. But then there's also the other problem, which is application developers are getting a lot of pressure to deliver faster and deliver with higher quality. So the tooling tries to cover both of these areas. So we have like the things like Terraform, which allow you to do that lift and shift, where you can move your infrastructure over to cloud, where you can define it in a very sort of declarative way. So it's reproducible. You can put it into source control and versioning, which is all like awesome because it's a method that developers have been used to for a long time with our source code, right?
Right.
And it's also about adopting DevOps. So it's about getting operations and developers to work together to solve the problems that we all have. I mean, like, infrastructure is not just an operations problem. It's something that we all share. So
That sounds like magic, right? What you just said.
It's magic.
No,
it's declarative magic. So it's reproducible. It's
perfect.
It's awesome. So onto that like kind of that cloud adoption thing, you've got your traditional data center, and then that's kind of made up with your application servers, maybe your databases, your networking, and stuff like that. And what people kind of want to start doing is taking this core infrastructure, taking the application platform and the security, and security in a sort of the private data center is more often than not, it's kind of thinking about things just like a firewall.
Right.
But you then sort of start to try and migrate that over into the cloud. And the first place that most people look at is infrastructure. So that's kind of like the first layer to kind of tackle the problem. And then once you've got your infrastructure in place, you start asking, well, how do I start running these applications? And these can be a combination of modern applications. So it can be things like Dockerized or containerized microservices, but more often than not as well, you're dealing with kind of legacy applications. So some of the things that we just sort of seen with Habitat and like a lot of Java-based applications, you need to figure out how you're going to get that to run on your modern.
I think you got your clouds mixed up here. I think Azure is supposed to be before AWS. I'm just saying that, you know, if you were to redo this slide, Azure Cloud should be before AWS.
I think we just did it alphabetically.
Oh, okay.
Yeah.
Okay, we're
No,
good.
we
We're
don't-
good. No beef. No beef. We're good.
So then, I've lost my place now. I completely lost track of where I was. So we start putting the applications in place. And then the next thing people start looking at is, it's like, well, the old concept of just having this perimeter security, this firewall is not really good enough anymore. So have to start thinking about how we can have a more modern sort of approach to security on our new systems. So we kind of try to break this down into these sort of three areas, which is run for your applications, secure for your infrastructure and your applications, and then provisioning, which is like Terraform, and we're going to look at today.
So the security layer there, can we talk about that for a second? Because security is very important, and I think that many companies have different definitions of security.
Yeah.
So if you wanted to like dive into that a little bit, what that means to you guys at HashiCorp.
So I think for us, it means like zero trust. So it's sort of looking at everything as a potential threat and trying to deal with that on a very sort of micro level, as opposed to just sort of wrapping everything up in this perimeter security. Because I think one of the things that we see from a lot of the recent attacks that come out is that perimeter security is not good enough. I mean, people will find exploits in application frameworks, and then they'll use that to be able to bypass your perimeter security and get inside of your sort of clusters and networks. And once they're inside, if you don't think about how you're securing things like secrets, passwords, database credentials, access, running things like TLS between your services, then it just makes it very, very easy for that potential attacker to then like exploit anything that's going on there. So it's interesting you say that, because we've got a really great product which deals with security as well. But
Your soothing British accent makes me believe everything that you say, so.
it's absolutely true.
Yeah.
In addition to that, though, what you also have is a necessity for being able to connect all of these parts together. So generally the first problem that people find out when they start working with microservices is, well, how do these things talk together? So like communication's easy enough. You can just use HTTP or TCP, but how do you do service discovery? How does one application know the location of another one in this kind of dynamically shifting environment? So the kind of the connect layer where you can provide that capability is incredibly important, which is where we kind of bring it down to the open source products, which is for run, there's Nomad, which is a scheduler like Kubernetes. You
Right.
have Vault to manage your security, so all of the things like TLS, secrets, and all of that sort of great stuff. And Terraform, of course, for provisioning that infrastructure, which is the thing we're going to look at today. But then you have Console, which kind of sits as that fourth layer and can manage things like your service discovery, configuration management, and stuff like that. And in addition to the sort of the open source tooling, we also offer the enterprise, which has additional features, so like Terraform, workflow management,
Sure.
and replication and high availability, which go beyond the open source. And that's the end of the
That's the end of our slideshow. Does
the
that
end
mean
of the
demo?
slides. It's demo
that's,
time.
That's cool. All right, let's do it.
All right. So what we're going to have a look at is building up some configuration in Terraform to create a Kubernetes cluster in Azure. So what I'm going to try and go through and explain the kind of the concepts and the bits and pieces. So if there's like anything, just like stop me and
Oh, we cannot see your
oh, you can't
demo,
see my
sir.
demo. That's okay, because that
live
means
is cool.
it's probably going to work better if you can't see it.
Exit out of PowerPoint is what they. Oh, look! It's right there. How about that?
It's been there all the time.
Good job. Yeah. Been there the whole time.
So the first element that I want to kind of add is a thing called remote state. And state's really, really important in Terraform because your configuration defines what will be, whereas the state defines what is. So then obviously the difference between that is what's going to happen. So managing state is really important, and you kind of don't want it lying around on a computer. You kind of want to put it somewhere safely, and I think remote state is an excellent way to kind of do that. So we're gonna use some container blob storage in Azure to manage our state, and we can do that just by adding this configuration block here.
That looks easy enough.
It's super easy, cut and paste straight from the documentation. And then the next thing we want to add is the provider. So the provider defines the kind of the top level. So you have a provider, in this instance it's Azure RM for
Sure.
the Azure API. And then you have resources which kind of sit in there. So when we set up our Terraform configuration, we need to be able to set up our provider with things like the access keys and the subscription and stuff like that. So let me just quickly add those in there. And again, I can't multitask, so.
Well, luckily nobody's looking at your face, so we're good. I mean, except for the audience, they can totally see you.
Oh, they can totally see.
Yeah.
So what I'm adding is I'm just replacing the placeholders I've got here with some variables which I've defined. And the kind of this syntax that I'm using, where I'm using the dollar and then this sort of curly bracket, is interpolation syntax. And what that allows me to do is it allows me to replace, when I run Terraform, it'll replace the contents of this dollar curly bracket with the sort of the interpolated value, which is going to be the tenant ID,
Sure.
which is variable because it's prefixed with var dot. And I'll explain a little bit more once I've kind of finished this up. But variables are super useful. I mean, they allow you to make your configuration really sort of dynamic and reusable. And I think this is kind of a key thing. You want to kind of try and make configuration reusable. You want to make it modular. So you can share it. You can kind of do that write once, use many pattern. It's the same as you would do with code.
Yeah.
And it also means you can just download a whole bunch of stuff from things like the Terraform module registry and Stack Overflow, and
Oh, that sounds lovely.
which is the perfect
Yeah.
development flow. So I'm using, so for example here I got subscription ID, and
Right.
in subscription ID I'm defining a variable. So what I've got to do to use a variable in Terraform is I've got to define those variables.
Sure.
So this is kind of like the definition. You can see on like some of them, like the SSH key public and stuff, I'm assigning a default value, but I don't have to assign a default value. What I do have to do though is that there has to be a value for this variable when I come to run my configuration. And I can kind of provide those in a number of ways. So I can inject them using the command line flags. I can provide them in a file. I can use environment variables, or I can kind of use a combination of all of the three. So it's very flexible, so that we're kind of taking into account all of the various different workflows that people want to use. So you might want to use environment variables if you're using CI, or as an organization, you may say, file-based is the best way for us.
What's best practice?
I think it depends on what you're going to be doing. So I think you've got some secrets in here. So I've got things like client ID, and I've got client secret. I don't really want that to leak, so I don't want to be committing that to a public GitHub.
Right.
So what I like to do is I like to use environment variables, and one of the sort of, there's a utility for the Mac called direnv, and what that allows me to do is it allows me to have an environment variable file per sort of directory. So every time I change into a directory, it'll set these environment variables, and I can make sure that file is emitted from GitHub. So it gives me that kind of workflow. And then when I'm running on CI, so if I'm running this job in Jenkins or something like that, then I can just provide those environment variables into the Jenkins job. Or if you're doing something more sophisticated, you could use like Vault and all sorts of stuff like that. So there's a number of ways to do it, but I think the key thing is make sure that they don't leak anywhere public. Otherwise, you can end up with a bill that you don't want to pay.
Wait, what if you're a silly Windows user?
You could probably use some stuff. Are you like well, you can still use environment variables.
You can do that.
You can do stuff. I think it's a great opportunity when we're talking about open source.
Yeah.
So if direnv doesn't work on Windows, then it's a great opportunity for everybody out there to go out and port it to Windows, right?
Go build it.
Yeah, and maybe write it in Go as well, because then it's totally cross-platform.
Yes. There you go, Tyler. JK, love you, Tyler.
So that's kind of our top level. But what we want to do is go and create some resources. So let me just, this multitasking is really difficult.
Yeah, I get you.
So then I need to create I don't need to create, I'm going to create a resource group, and that's kind of giving me that top level for the various different bits and pieces that I'm going to create in Azure. And
you keep saying I don't need to do something, but I'm going to do something.
Yeah, so this might already exist. So you might already have a resource group that's provided to you by your sort of operations team or something. I don't have one, and I need one for my configuration. So I'm gonna create it here.
Because if it's optional, I'm not going to do it.
Yeah. So you got to do it. You need one.
Okay.
You do need one, but
all right.
Yeah, you might not need to create it.
All right.
Yeah. So then the syntax for a resource, and a resource is literally a resource in Azure, is that you have the keyword resource, then you have the type. So in this instance, it's Azure RM resource group, and then you have the name of the resource. Now the name is not what it'll be named in Azure. It's a name that's going to be used in Terraform so you can reference it later on. I've imagined it'll be called this default, which is an appropriate name because I literally am only going to create one resource. But naming the names do have to be unique. So if I have two resource group types, I can't have them both called default.
Sure.
Terraform will complain and say, you've got to give them unique names.
That's good practice. Thanks, Terraform.
Yeah. So again, we can use interpolation, and I'm going to use the namespace as the name of my resource group, and then the location, which is the kind of the Azure location, which I think I'm using West US 2. I'm just going to specify that in there again. So again, very, very simple, just using the interpolation. This is creating this. It's very dynamic. I can provide a lot of this information at runtime. And then on to the complicated stuff, which is really not that complicated, thanks to some lovely people who've created the managed container service.
Yes.
So what we're going to do is we're going to add our Kubernetes.
Oh, wow, look at that. How about that?
And this block is pretty much literally cut and paste from the Terraform documentations. I mean, I'm not smart enough to figure this out myself, so
sure.
I think stealing code is a much better approach to working.
Why write code that already exists?
Exactly.
Why do that?
So we can, again, just go through, fill in some of the details. So var namespace. And what did I call this? K8's cluster name. So what this is, I can actually use multiple interpolations inside. So I'm going to create my name, which is hyphenated namespace, and then the K8's cluster name.
Sure.
Location. Again, I'm just going to use my location variable. Now the resource group, so I need to provide the resource group name. And what I could do is I could hard code this, or I could literally use the same name that I used in the previous block when I created the resource group. But what I can also do is use the interpolation syntax. So I can reference the name of the resource group as, so it's the type, so it's Azure RM resource group. And then I'm going to use the name that I gave it, and I imaginately called it default.
Perfect.
And then I want to get the attribute from that resource group, which is name. And you can find all of the various attributes and the outputs and inputs on the Terraform documentation, and they do kind of loosely adhere to the Azure API if you've been using that before.
Yeah, and I want to add that the Terraform documentation is actually really great.
Yeah, it's really great.
So congratulations on that.
Thank
Great
you.
documentation is important.
I will take full credit.
As you should. Why
Yeah.
wouldn't you?
But so I think the other interesting thing about doing this interpolation in this way is that because I've referenced the name of the resource group in my interpolation syntax, I'm actually giving Terraform a hint to tell it that it needs to create the resource group resource before it goes ahead and creates the container service. So by building up your sort of configuration and using these links, Terraform's able to build a graph of all of the various different dependencies. So it knows what it can create ahead of time and what it can sort of delete and all of the various different bits and pieces like that. And then, again, I can go through, fill out all of the various different bits and pieces. I think this key data is something that's worth noting, because what I actually need to provide in the key data is the contents of my SSH public key. Mm-hmm. So in addition to sort of just using interpolation for links, I can actually use some of the inbuilt functions. So I can say I want to use the file, which is going to load the contents of the file, and then I can sort of give it the path, which I'm defining in my variables as public key. Like that. And then what that will do is when at runtime, it'll go read the file and it'll insert the details into that attribute. And that's pretty much all you need to do to kind of set up container service. So I'm going to literally I can run Terraform plan, Terraform apply, and we'll see that up and running. So this takes about sort of 15 minutes to run, so I'm not going to do that. I've prepared one earlier.
Yes.
But what I can do is I can very, very quickly show you how we can deploy an application to Kubernetes, which again is going to mean you have to stand and watch me typing a whole bunch of stuff again.
I enjoy watching you type. I don't. I'm just kidding.
I don't think any. So again, so this is an interesting element, because I said I was using remote state in the other one, which means that the state is stored in container storage.
Yes.
Now what I can do, because in my application configuration, I need some of the details from that state. So I need things like my Kubernetes certificate so that I can connect to the cluster, and I need like the address of it and things like that. because it's remote state, I can actually read the remote state from a separate piece of configuration.
Nice.
So it gives you this like really nice ability to have like a core infrastructure and then an application infrastructure. So maybe your core operations team are going to manage your main clusters, but your application developers should be able to get on and just kind of write their own configuration to deploy to that cluster. And remote state gives you that capability. It gives you that read access, but it doesn't mean that you can kind of mutate the state. So I can't accidentally delete the core infrastructure cluster, which would be
unfortunate. That would be
it'd
unfortunate.
be a bad thing. Yeah. Wow. So then what I can quickly add is my backend, and I'm using Terraform Enterprise. So in the same way as previously, I was using container service as my backend. I'm going to use, for storing my remote state, I'm going to use Terraform Enterprise for this one. And then again, specifying the provider for Kubernetes. So this is the same as the provider for Azure. I need to give it some certain information, such as like the host, the client certificates and stuff. And I can fetch that out of the remote state. So I can use the data element, and then I can say Terraform remote state, and then the name of it. So I want core, and then the element that exists in that remote state. So in this instance, it's K8's master DNS, and then exactly the same thing for the other elements. So data dot.
I'm going to let you type through this and stop bombarding you with questions for the sake of time.
Yeah, it's. I could have just cut and pasted all of this in, but then
That's my favorite
that would
thing
have
to
probably
do.
meant the demo would work. And everybody wants to see a failing demo. Nobody
I
wants to see a
certainly do,
working
yeah.
one.
Oh, but I do feel bad about the dead air. I do feel bad about it. I'm not gonna lie. I'm not a good singer though, you guys. So I'm not gonna sing you a song.
I'll try and be as quick.
Ken wants to know if you can smile while you concentrate.
No,
No,
I can't do that.
no, absolutely cannot, Ken.
That would be multitasking.
No.
So then we create that. Then we can add our Kubernetes application. So again, I'm using Terraform to provision that. I'm going to create a pod using the Kubernetes pod resource, and this kind of loosely translates to the sort of the YAML files that you might work with if you're using kube control.
Are you missing an R in Terraform, Nick? Somewhere?
Possibly.
Yeah.
Possibly.
Computers are hard, I get it.
Hopefully it's going to tell me before I
That would be nice.
commit that. So again, filling in the things, I'm going to put the image. I'm going to use a very simple HTTP echo, which is just going to do pretty much glorified hello world.
Perfect.
And I'm going to spell that correctly. And I'm going to try and spell that correctly again. The name of it, I'm just going to call it HTTP echo. And I need to specify some arguments for the startup argument, which is listen and what I want it to HTTP echo, which is hello.
How Oh, the W was fine too. Yeah. Put some flair on it, Nick.
Hello OpenDev. We specify the container port, and then that'll create the pod. But if I want to create the pod, I also want to expose it to the world, so I need to create a Kubernetes service.
Sure, you might want to check in remote state for that extra R.
Oh, I'm going to check that.
All right, cool. Yeah. I'm worried about the R.
It'll... So we're going to... Whoops. Again, we're just going to create a service, fill in the namespace, and then the application link. And again, this is using the interpolation syntax, so I can specify Kubernetes pod.app.
What snippet manager are you using?
I use Alfred, which is pretty awesome because I've got the memory of a goldfish, which means that I just can't remember a single thing. So that's all done there. Very, very finally, let's add a DNS entry record, and I'm going to use multi-provider, so I'm going to use simple DNS simple to be able to do my DNS records.
They have some of the best stickers. I just want to shout out to Simple.
I don't own any of those. So if they want to send me a care package, I'd be...
They're so good.
So DNS, TLD, and the app link, which again is going to be a link to Kubernetes. So it's going to be Kubernetes
I think
service.
They should change it to a Z.
It should just be all changed to K8, so I don't have to type as much. Load balancer ingress. And I want the first IP address.
You might want to check balancers.
Yeah, totally.
Yeah.
Okay, something like that. And then let's see, where did I spell that? Terraform wrong?
No.
Oh, there. There we go. Ooh.
You're not helping.
I'm not.
Okay. Oh, there's that R. Oh, thank goodness.
So then, now I've got that done, I can just do a quick check. So I'll run a Terraform plan. And that says it's going to go away and it'll create three resources, which is cool, but I don't want to run this from my local machine, so I'm going to add this to GitHub.
As one does, yes.
And I'm going to push it, and I'm going to let Terraform Enterprise do all of the planning and applying from my central location, updated stuff, because cohesive commit messages are important.
I agree.
And then I'll push that.
Is it gonna work?
That is the question.
Look at that. Look at that. It's in the dashboard and
so then that's picked up. So it's running. It's also telling me that we've got a brand new version of Terraform, 10.8, which literally must have just been released this morning.
Oh, what a coincidence, Nick.
Which will be amazing because I've now got something to blame. So you can see that, again, it was the same thing that I ran last time. So the plan, I can see that in here. Now the workflow of kind of TFE allows me as a developer to push that. Somebody can validate, and then I can just kind of say, okay, looks good. Hit confirm and apply. And then Terraform's going to go away and it will provision that pod in Kubernetes. Fingers crossed, pray to the demo gods. And this is going to take a couple of minutes. So
Perfect.
I don't have any, I'm not very good at singing either.
Yeah, you're not very good at singing either. I agree with that. So what about okay? So we talked a bit about Terraform Enterprise. Can we dive into the details for the poor people like me who don't want to use the enterprise version because they want to be with the people?
Yeah, so actually the Terraform commands and all of the configuration that I ran is part of the open source. All that enterprise does is adds an additional sort of workflow layer. I mean, if you're not an enterprise, then open source is probably more than good enough. And you can still kind of use open source with things like Jenkins and GitHub pull flows and stuff like that. So you can get all of those features. I'm literally just showing TFE because I was too lazy to set up a Jenkins server this weekend. But we don't in any way kind of cripple Terraform or any of our open source products, which kind of force people to upgrade.
Yes.
The capabilities are there. Generally, if you are an enterprise, then you probably need those extra things, and then that makes it a sort of a sensible upgrade. But yeah, the basic stuff like in the open source is pretty amazing. It's no way like feature crippled or anything like that.
I love hearing that. Also at HashiCorp, we talked about Terraform it being in the Azure portal.
Yes.
I saw that you had that up if you wanted to like
so you
show
can
it real quick.
You can actually from the cloud CLI, which one shall I use? I'll use Bash and Linux. I'm going to create some storage. So you can actually call Terraform based straight out of the cloud CLI. It's Terraform's already loaded in there for you to use.
That's rad.
Yeah, it's super cool.
I mean, oh snap.
It's just initializing my account. I don't know which is. We kind of found two parallel processes which were long running, what we had to wait for.
You know, Seth, nowadays the kids say that's totes cool.
I'm old, so I was going for 90s.
Yeah.
Yeah.
Yeah, you did that.
Yeah, I went there.
So what this is, because Kubernetes is going to create the load balancer in Azure, so that's going to take a little while to provision those services, but it hasn't failed yet, which is for me, and it worked.
Oh my God, it worked.
I shouldn't be surprised, should I? I'd be like, yeah, of course it worked.
No,
Be like,
I'm happy. I'm sad. I wanted it to fail.
Everybody wanted it to fail.
We
and
all
look,
did.
it really works as well, because, hello, OpenDev. Oh, and I spelled OpenDev wrong.
Yeah, well, you know, you spelled a lot of things wrong today, Nick. So.
I'm pretty good at spelling things wrong. So that's pretty much it. That's Terraform in sort of like quick sort of 30-minute overview, but you can go ahead, you can create your managed Kubernetes service on Azure. You can write the Terraform configuration for your deploys. There's no magic. It's all declarative. You can commit everything to GitHub. Full version control. More important than version control for me is the capability of Git blame. Now, I don't advocate Git blame, but it's a thing, and it's incredibly useful. Put your config in there, and you can see who screwed up your cluster when they created bad config.
Yes. So we have about 4 minutes left. What are some great resources for people if they're just getting started? And also, I don't know, if people have been using it for a while, what are some like weird resources that maybe they don't know about?
So I think there's one of the things we announced at HashiCorp is the Terraform registry. And what we're trying to do with the Terraform registry is bring all of those community modules together. So it gives you the capability of just kind of saying, hey, I need some resources like a load balancer in Azure. So rather than write the Terraform configuration by hand, you can just leverage a module which the Microsoft engineers have written for you. And then you just load that in as a module, give you all of the various different sort of resources that go into creating a load balancer, and then you can kind of build up your infrastructure using this modular configuration. And again, because it's It's modular. You've got the capability that you can update modules and you can do things like versioning modules. So it kind of, it'll give you a starting point to look for things, but also it'll get you up and running super, super quick. So definitely check the registry out. I think the Terraform website itself is sort of, it's got pretty comprehensive documentation on all of the provider. And you'll actually find documentation on all, I think there's like 70 providers or something in there now.
That's extensive.
Yeah, but you'll find all of the things in there. And likewise with the sort of the registry, what you're going to find is a bunch of cheat sheets as well. So if I want to create an Azure MySQL server, chances are I could probably just cut and paste this block into my configuration, run my Terraform plan, Terraform apply, and I will have a MySQL server in Azure, which is just awesome.
That is awesome.
And I think we where occasionally we'll do webinars. I think we've got a webinar tomorrow where we're going to look at some best practices around Terraform.
Where can people find that? I'm sure that you'll tweet it out.
Yeah, we'll definitely be doing that. But if you go to the HashiCorp website, and we are hiring as well.
You are also hiring,
We are also hiring.
All you people in the audience, no, don't do it.
Yeah, so there's a webinar tomorrow about sort of how the best practices around collaborating on infrastructure as code. And if you hit the HashiCorp website and then go to resources, you'll be able to find the free registration button there.
Very cool. And on the website, you guys also have a spot for use cases, right?
Yeah.
Very good.
Yeah, so the HashiCorp website is a kind of a link off to all of the sort of the independent sort of documentation sites for Console Nomad, Terraform, and Vault and things like that. So it's a good sort of landing page. We've also got some. I really like some of the sort of the things that we've put on. So if you're thinking about sort of adopting cloud, or if you're kind of looking at a way of sort of saying, well, hey, how do I sell DevOps? We've got a whole bunch of white papers as well that you can sort of download, rip off, and pretend it's your own information.
Yeah, no, you guys were really thoughtful with your website. Appreciate that. And we are out of time.
You have a guest, though, don't you?
Oh, we do have a guest, but...
You can, it's okay. We're all friends here.
Vicky.
I want to hear what she has to say.
I do too. I felt bad for Vicky. Vicky's sitting there. Vicky also has a box.
I'm just going to awkwardly insert myself.
Please
on this box.
do that.
Hey.
Hi. How's it going, Vicky? You sat over there. Well, Nic just droned on. He just took all your time. What's going on? Oh, sweet keyboard, by the way.
Thanks. You too.
I know.
Cool. What was I gonna do? Oh, yeah. So I'm just gonna show you how we use Terraform on Azure and OpenAI, and we totes use all the things that Nic just said. So
Totes. Seth.
Is that a new age thing too that I need to learn? Totes.
Yeah, totes.
Okay.
yeah. Cool. So it's not working. Okay. So quick thing about OpenAI. So we're a nonprofit research lab, and we. Oh, flip my hair. Okay.
Being live is cool.
We do a lot of basic AI research with a goal of save artificial general intelligence in mind. So, and to that end, like more concretely, we're working on a lot of different projects that we think will push us towards like different breakthroughs in AI and various fields. So one of the biggest ones that we've recently released is the game playing Dota bot. And so that is we had the bot play in like an international tournament with like pro esports players, and we won.
That's nice.
And then like some of the other ones that we've kind of talked about are robotics, and currently we're working on like manipulation, and we're also doing safety, obviously.
Yeah, all of those things are fascinating yet terrifying.
Yeah, they are. So, and then, well, on many levels. So one of the things is their demands on the infrastructure, because we have so many like projects that are so different. So one of the things is how workloads differ on scale depending on the like life cycle of the research that they're in. So when you're like a researcher starting out, you're really playing with like a couple of toy experiments, and maybe you just need like 8 or 16 cores or something.
Right.
But then going to like scaling up to play Dota, then we're going to start to talk about like tens of thousands of cores for like one single experiment.
Wow.
So the infrastructure has to be super flexible, and because the different teams are on like kind of different stage of the life cycle, then we need to make sure that if they start scaling up or maturing, we can just bring up whole new infrastructure catered to their needs. And that's why Terraform is kind of like godsend, because we can just like copy this module and like replace it with some different variables and just like launch a cluster in an hour.
Bacon's story is cooler than yours, Nick.
Well, I was leading up. I didn't want to.
So I wanted to show a little bit about how we use Terraform, and we have this like central Terraform module that just call it like the cluster. And within this module, it like references a bunch of submodules that bring up like the network, the storage, and like all the peripheral things that you need for a Kubernetes cluster. And we actually built our Kubernetes cluster from scratch because we wanted to make sure that it's like flexible for research. And then like
overachievers.
Well, we also just because we started using Kubernetes when like it was like kind of still a baby project, and so like all the things like weren't there, and then we just kind of kept going. So and then you can see like we use the same module but just plug in like different credentials and like different VM configurations, and we can say have like a dev cluster, a CPU only cluster, GPU, and so on. And then so now I think we regularly operate 3 to 4 clusters, and whenever there's like a deadline or whatever, we might bring up like more. And then we have so many clusters. It is great.
So many. Oh, look, the parrot. I love that parrot. Why do so many people hate that parrot? I love that parrot.
Yeah, it's all over our Slack. So
It's as it should be. Parrot's fantastic.
Yeah, so let's see. Okay. So just very quickly, like this is how our Terraform module looks in our dev cluster. So we have like the Atlas or the Terraform Enterprise backend, and then we have also reference a separate Terraform project that we depend on with like our core infrastructure. And then we have the cluster module that like brings up the Kubernetes masters and like all the networking and stuff like that. And then we configure like different types of workers that we're going to use. And of course, we end with a Jenkins module.
Man, that's beautiful. Look at that.
So, okay, let's see. I hope no one's changed anything in the cluster this morning. Oh, great.
Oh, cool. Yeah.
Yeah, that's totally. Oh. I see what happened. I changed it.
This is how programming really works, guys.
Yeah. It's like bursts of like streaming red text.
Yeah.
Cool. And hopefully no one on the team is doing anything on this cluster. And great. Oh, okay. So our cluster is ready to go. And I don't have anything running right now. So I guess I can just run a thing like kind of on the toy end of the spectrum, like what people do on our infrastructure. So our internal infrastructure team is very small, and that's why Terraform is great, because we can like manage our infrastructure as code. And basically anything that people bring up like manually that's not in the code is like totally cool to delete. So we just want to make sure everyone writes their infrastructure as code. And then we are like, this is like an internal product. So the researchers use our infrastructure as like a service, and then they like interact with the Kubernetes API directly. So, okay, let's see. So I'm just going to run this one experiment. It's a lot of layers.
Nice. So explain what's happening right now.
Yeah, so when we kick off the experiment, we first do Docker build and then Docker push. And most of the time, well, because most things are already cached, so that's pretty quick. And then we start, we launch jobs on Kubernetes and services, and we also bring up a tensor board so people can, like, in real time monitor their experiments.
Nice.
So, let's see. Okay, so we have all the things that are, okay. Yeah, we're not on 1.8 yet. So. Okay, so let's see what I can do. I just want to make sure that we can launch this quickly. This is our dev cluster, so. So hopefully things can get scheduled.
This is all very fascinating, actually.
Well, let's see why it's not scheduling right now. Of course, this happens right now.
I like it live debugging. Oh, it's my favorite. Makes me feel human, you know?
Why is it pending? No. It's the worst. It's going to-
This happens to the best of us, you know?
Yeah.
It's like 90% of my life is what's happening to you right now.
Oh, great. It's creating. Cool. Okay, so it's pulling Docker image.
Come on, Docker.
Yeah.
I like how you do, yeah.
Oh. Nope. It's not doing a thing.
Come on, we can do it.
Well, I figured like something like this might happen. So in the meantime, I'm like, so this is like a toy example that like usually finishes training in a couple minutes.
Yeah.
But of course, like if you let it go for hours, you're gonna get much cooler results. So for example, some of the things that you can do is like, so a lot of our experiments require like a simulator.
Yeah.
So we run like the simulation on the CPU, and then we run the machine learning on the GPU. And then our Kubernetes cluster usually has like mixed VM types. So we have like a bunch of CPUs and a bunch of GPUs. And then they talk over, well, sometimes they talk over the flannel network, but sometimes that's not good enough performance. And then we go straight to the host network. But anyway, so that's kind of like a very basic setup. And then you can start doing like things like this, where like
That is so
can actually
cool.
do things. And Docker is still doing Docker things, so.
Come on, Docker, we're counting on you.
You should have prepared that song.
Well, yeah, no. Ugh. So if people want to find out more about this, where would they look?
So most of our things are on openai.com, or like check out our GitHub. Oh, look, it's
Oh,
like
look at
learning
it.
to walk right now. So it's not very good. It's like, so
That's how Nick was walking this
Is that
morning.
a video of me getting up this morning?
Yeah,
Oh,
yeah, we didn't want to tell you. But
yeah, weird.
Yeah.
Yeah, it's gonna do that for like a few minutes, and then it's like.
And then
learn to
it's
walk.
gonna
Yeah.
it's gonna learn.
Yeah.
That's really cool.
Yeah, sometimes it just looks like it's like tiptoeing. It's
Yeah.
like walking like this.
That
Yeah,
is
it's super weird.
rad.
Yeah, so all of our kind of, if you want to just like try running some of these experiments, a lot of the code is already on our GitHub, and we publish like baseline algorithms so you can just like clone it and run. And we also talk a lot about our infrastructure on our blog. So
I want this in a GIF so I can tweet it out, being like me going through life like.
oh yeah, I know we
Nice,
have
you
many.
know.
Some of them look like they're just like super drunk. And,
It reminds me of prom when I went. That's what I look like
Oh,
dancing.
you went to prom? Lucky.
No, I didn't. My mom took me.
Yeah, typical. Classic Seth. His mom also drove him here. Just want you to know
True.
that.
cool.
All right, very good. That was really cool. That was much cooler than Nick. Sorry, Nick. I'm kidding. I love you, Nick. You're my favorite. I mean, Seth is my favorite, so we're going to go over to Seth.
Let's give him a hand, though. That's